All right, so in this video here, we're going to be talking about solving logarithms. And in order to do this video here, you have to know properties of logarithms. So make sure you know how to do that. I'll go ahead and link that video below on properties of logarithms. But assuming you know how to do that, let's go ahead and get right into these examples here and talk about how we're going to solve these log equations. So the first thing that we're looking at right here is that we have the same base. You can see here that I have a base of 9 and a base of 9. So based on our log properties, if we have the same base and we're subtracting, we can actually rewrite this problem as a division problem. So for example, I'm going to rewrite it as log base 9 and then of, and then you go left to right reading it like a book. You're going to do 10 over negative x. So I'm going to put here 10 over negative x and then all equal to 1. All right. And then from here, we have to go ahead and solve the equation. And we're going to do that by using the inverse property. Now, I have a base of 9 here. I have this logarithm base 9 and then of the following. Now, how do I get rid of that logarithm? Well, we're going to use the inverse property, meaning on both sides here, I'm going to change the base to 9. So for example, I'm going to have a base of 9 all to the power of log base 9 and then of 10 over negative x. Equal to, now what I do to one side, I have to do to the other side. So this 1 here, I have to do 9 to the first power. And that's balancing out the equation. And now we have the inverse property right here. And the inverse property states that, well, if I have a base of 9 raised to a logarithm with the same base, in this case here 9, it will essentially cancel out and become 1. So this right here will cancel out. And now I'm left with 10 over negative x equal to 9. And from here, you just have to solve it. So what we're going to do here, I'm going to multiply both sides by negative x. So multiplying both sides by negative x will cancel here. Multiply this side by negative x. And you can probably see what's going to happen here. I'm then going to divide both sides by 9. And then I'll have negative x equal to 10 over 9, right? Dividing both sides by 9. And then I can't leave the negative here, so I'm going to divide both sides by negative 1, meaning my final answer is going to be x is equal to negative 10 all over 9. And there it is. Okay. All right, let's go ahead and try another example. So here's our next example. Same thing. We have the same base right here. We have a base of 2, a base of 2, and a base of 2 on the right-hand side. And I'm doing subtraction, meaning I can use division here to condense it down. So I'm going to say here log base 2 of, and then going left to right, I have negative 4x over, and that will be 3. All equal to log base 2, and then of 8. Now, we don't need to use the inverse property here, where I make a base of 2, and then I'll cancel out the logarithms. I don't have to do that, because actually I have the one-to-one property here. And the one-to-one property simply means if you have a logarithm with the same base on both sides of the equal sign, like I have here and here, they will cancel each other out. So for example, you're going to be left with, well, this will cancel, and I'll have negative 4x over 3 equal to 8. And then I can go ahead and solve for x. So doing that, I'm going to have to multiply both sides by 3. That will give me negative 4x equal to 24, right? 3 times 8. And then dividing by negative 4, I get negative 6. So I get x is equal to negative 6, and I am done. Here is my final answer right here. Okay, so let's go ahead and try 2 more examples. So here's our next example. This one's a bit different because we have addition, but we do have the same base here and here, meaning we can use properties of logarithms. And if you have an addition sign, meaning you're adding, we can actually condense it down by using multiplication. So what we're actually going to end up doing, we're going to do x minus 9 times x. So when you do that, you get log base 2 of, well, x times x will give you x squared. And then negative 9 times x will give you negative 9x, right? And then equal to 5. And then from here, we're going to have to use the inverse property. So using the inverse property, I make a base of 2 here and also here, right? And so essentially what's going to happen, this will cancel out. I get x squared minus 9x. And again, this really is 2 to the 5th power. It looks a little weird how I wrote it, but I didn't feel like rewriting the problem. But that is 2 to the 5th power. That will give you 32. So equal to 32. And so from here, we have to solve it. And you can see that I have a quadratic. So to solve quadratics, we set them equal to 0. We try to factor. If we can't factor, then we'll go ahead and use the quadratic formula. So I'm going to take that positive 32 and move it over to the left-hand side. So I get x squared minus 9x and then minus 32, all equal to 0. Okay. Now I'm going to try to factor it using the AC method. So doing A times C, A is 1, C is negative 32. When I multiply them, I get negative 32. So I need two numbers when I multiply that will give me negative 32, but add up to my B value here, which is negative 9. Now when I'm saying B, I'm talking about a quadratic in standard form, which is ax squared plus bx plus c, right? So I'm talking about this value right here. And in our case here, it's negative 9. So I need two numbers when I multiply that will give me negative 32, but add up to negative 9. And you're going to figure out that those numbers do not exist, right? So what we have to do here, we have to actually use the quadratic formula. No big deal. So why don't we go ahead and scroll down a little bit here. And using the quadratic formula, we're going to get the following. We get x is equal to negative b. Now, my b here is negative 9. When I plug it in, positive 9. So positive 9 plus or minus square root of b squared. Well, that's going to be negative 9 squared. That will give you 81. Minus 4, my a is 1. My c is negative 32. And then all over 2 times a, that's going to be 2 times 1, so 2. And then we're going to clean up what we have underneath the square root. So continuing on here, we get 9 plus or minus square root of 81. And we have to do negative 4 times 1 times the negative 32. That will give us positive 128. And then again, all over 2. So all over 2 here. And so now at this point here, we're going to go ahead and add up 81 and 128. We're going to get 209. So we get x is equal to 9 plus or minus the square root of 209, which is not a perfect square. We're going to leave it like that. Square root of 209, that's fine. All over 2. Now you have two different answers here, and you want to make sure you're checking for extraneous solutions, meaning if I plug in one of these solutions into the original problem, will it make it undefined? And well, if you do it in your calculator, if you do 9 plus the square root of 209 divided by 2, you end up getting a positive number, okay? So if you go all the way back up to the original, if I plug in a positive number, and in particular, it's going to be positive 11.72. And so if I plug in positive 11.72 into x, will I get a negative number inside here? And I won't, right? I'm going to get a positive number here and also a positive number here. And we don't want to have a negative number because you can't take a log of a negative number, otherwise it will be undefined. So that positive version is going to be fine, meaning the following. We know that x equal to 9 plus the square root of 209 divided by 2 will in fact be a solution. I'm going to go ahead and box that in, okay? But if we check the negative version, if you do 9 minus the square root of 209 and then divide by 2, you end up getting negative 2.72 or negative 2.73, depending on how you're rounding it. Well, if I plug that number back into the original, will I get a negative? Meaning, if I plug it in right here, again, it was negative 2.73, okay, about. So if I plug that into x, will I get a negative number? And I will. I'll get a negative number here and also here, meaning that's going to be undefined, meaning that solution is going to be extraneous. We are not going to include it. So the only one we're going to include is right here, the one that we have boxed in. All right, let's go ahead and try one more example. Okay, so here's our last example. And again, we have a base of 5 here and also here. And we're adding, meaning we're going to condense it down. And when we condense it down, we're going to be multiplying. So I have log base 5, and then condensing it down, I'm going to get 5 times x, I get 5x. And then 5 times 1 will give you 5. And then equal to 2. And then I have my log base of 5 here. I'm going to use the inverse property to get rid of that logarithm. So I'll have 5 all to the power of log base 5 of 5x plus 5 equal to, I have to balance out the equation. So this 2 right here will now have a base of 5. I'll have 5 to the power of 2, okay? And now we're going to go ahead and simplify it down. So this logarithm will cancel out here due to the inverse property, and I get 5x plus 5 equal to 5 squared will give you 25. Here I want to minus 5 and then divide by 5. So subtracting 5, you get 5x equal to 20. And then dividing by 5, you finally get x is equal to 4. And there it is. Okay? So that is how you can solve log equations. It's pretty straightforward, but you do have to know properties of logarithms. So again, if you do not know properties of logarithms, go ahead and check out my video on properties of logarithms. I'll go ahead and link it below. That way you have access to that content. But that's going to do it for this video. I hope that you gained something from it. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.